Okay guys, we're going to do 10.5 today, modeling with exponential functions. Remember, a model is simply an equation, so we're going to be using exponential functions and finding exponential functions today. So number one, let's look at number 3. We're told that, let's see, we want to write a formula for the balance in an interest-bearing bank account if the balance triples in 20 years. So we're told balance triples. I don't know how to spell triples. In 20 years. All right, so what we'll have is we'll have capital B equals little a times little b to the t. Capital B is for balance. All right, well, we know B equals 3a when t equals 20. So what we can do is I can substitute 3a for B and plug 20 in for t, so we get 3a equals a times b to the 20. The a's cancel. 3 equals b to the 20th. Then to undo this exponent, we raise everything to the 1 over 20 power. So 3 raised to the 1 over 20 equals b to the 20th to the 1 over 20. These exponents multiply to give an exponent of 1, and we plug 3 to the 1 over 20 in the calculator to get 1.056 equals b. So then the answer is the equation. So we get b equals a times 1.056 to the t. Okay? Easy as pie. All right, so now moving on, let's look at number 4. In number 4, we're given a population's doubling time in years, and we want to find the growth rate per year, not the growth factor, growth rate. So we're told doubling time is 50 years. All right, so we want to find the growth rate. Well, we can let the initial value, again, be a, growth factors be little b. So we essentially have y equals a times b to the t, right? But when t equals 50, y must equal to a because we've doubled from the original. So 2a equals a times b to the 50. Again, the initial values cancel. 2 equals b raised to the 50. Raise everything to the 1 over 50 power. Plug this in your calculator, and you should get 1.014 equals b. But remember, this is the growth factor we're asked for the growth rate. So the growth rate r is equal to b, which is 1.014, minus 1, which is 0.014. So therefore we have 1.4% growth. That is the growth rate. Okay, then moving on to number 27. All right, in number 27, we're asked to find a possible formula for the exponential function. So here we have a cohort of fruit flies, initially numbers 800 and decreases by half every 19 days as the flies age and die. So we know our initial value is 800, and the half-life is equal to 19 days. So essentially we have y equals a times b to the t, but we want t in days. All right, you're always going to take a normal unit for t, but since t is in days and we're given 19 days here, remember the half-life means multiply by a half. So what we're going to use is we're going to use the initial, and then we're going to use 1/2 for the growth factor. But then since we multiply by a half every 19 days, the exponent is t divided by 19. All right, well, we don't really want this kind of stuff. So what we're going to do is you apply the 1 over 19 power here. So this is going to equal 800 times a half to the 1 over 19 to the t. We're using the power to a power rule broken up. So then you plug a half to the 1 over 19 in your calculator, and you get 0.9642, all raised to the t. So there's your formula. And that's how you do that one. Okay, in 22, number 22, is the next one. We're given a table and asked to find the equation. And I'll actually show you how to do this in your calculator. So 296, 376.8. All right, so this is the table that we're given in number 22. So what we want to do is very similar to when we use linear regression. We're going to use something called exponential regression. So we want to take this and put it in the calculator. So let's see if I can put it off to the side. Let's see how well we can do this. Let's see, so we turn it on. All right, so we start by pressing, essentially we want to get all this data in the calculator. So we press stat, and then we want to edit. Let's see, maybe like that. All right, so what we want to do is we want to put all the t values in L1 and all the f of t values in L2. So we have 2, 3, 4, 5. And then we press to the right and we enter these values: 96, 76.8, 61.44, and 49.152. All right, so now we have our data loaded. Here's our table. Now what we want to do is we actually want to run what's called exponential regression. So we press stat again. We want to calculate something, and then scroll down until you see EXPREG. And for me, it's at the 0th option, so the 10th down. So we press enter. All right, I have the what's it called? Stat wizard on. So this is fine. You can just leave it all like this. X list is in L1, Y list is in L2. You can calculate it. And this is what we get. We get Y equals A times B to the X, where A equals 150, B equals 0.8, so that means Y equals 150 times 0.8 to the X. Now if you don't have the stat wizard on, which most of you probably don't, all right, we do the same step here. You put all this stuff in edit, put everything in, press stat again, scroll down till you get to exponential regression, and this is what happens. The same thing, but we need to tell it L1, so second 1 is L1, comma, second 2 is L2. To tell it the X list is L1, the Y list is L2, press enter, and you'll get the exact same thing. All right, and this is our equation. Easy as that. All right, so that's 22. All right, so now let's look at 37. Let's look at number 37 now. So we'll start with another piece of paper. All right, so that's what, number 5 now. So number 37 says Chicago's population grew from 2.8 million in 1990 to 2.9 million in 2000. All right, so 2.8 million in 1990 to 2.9 million in the year 2000. All right, so what we're going to do before we start anything is we let T be the years since 1990. That makes our life a lot easier. We don't like actually plugging years into a function. So that means, therefore, if I use capital P for population, is going to be 2.8, because now 1990 is year 0, so that's 2.8 times B to the T. Right? So we want to figure out what B is. Well, we're told, using this information, when T equals 10, P equals 2.9 million. So what we're going to do is we're just going to truncate everything and just use these 2.9s and the 2.8. So that means 2.9 equals 2.8 times b to the 10. So divide by 2.8, you get 2.9 divided by 2.8 equals b to the 10th. Okay? So if you divide 2.9 by 2.8, you get 1.035714 equals b to the 10th. Now you apply the 1 over 10th power to each side, and we're left with b equals 1.003515. Alright, so we have our equation. P equals 2.8 times 1.0